The one institution that I know that does this regularly is the Naval Academy at Annapolis.
One of the things we're singularly focused on is having a curriculum that is responsive to the needs of industry. Southern New Hampshire University was asked to see what they could do for the students.
SNU owns a single-engine airplane, a Cessna 172.
After we learn about all the theory for a specific section, we'll go up in the plane and we'll test that theory experimentally.
So Professor Rosner, he did this exact process, working on doing the test flights for the F-18 aircraft. And so he's brought that process and brought it into the classroom.
In flight dynamics, each semester includes 3 flight tests. Each flight test measures different aspects of performance or stability and control.
Ours is very special because it has an MFDRS, or a miniaturized flight data recorder system, and that is what collects all of our data. So it collects GPS position, wind speed, altitude.
We can use those after we've performed the test to evaluate what performance features of the aircraft we're looking at.
But we also teach them the flight test process. They actually write a formal test plan that describes this.
We present that test plan to a board of people who would be able to then give us the go, no-go to do the flight test.
We ask the students to get faculty to sign that test plan, again, to represent what happens in real life, and then they execute the test itself as the test plan they wrote prescribes. They take the test plan with them in flight and tell the pilot, okay, this is the next maneuver we want to do.
Once we have that approved or implement any changes that they suggest, then we go out, carry out the flight test.
In each different test, we're looking at different things that the airplane's doing, different effects on the airplane for different things.
We'll be doing a spiral mode test where he's going to let the aircraft kind of fly along its path, and then it'll go into a steady bank, and then over time, after about 30 degrees, he'll come out of it. But if he were to keep going into it, we'd enter into what's called a spiral.
We have a realistic wing setup made out of aluminum, and we apply different loads to it, and we see how the wing flexes. We perform that same test using software and see what the differences are.
He'll set up different conditions of the aircraft, and then he'll enter into like a phugoid mode or a short period mode, and we'll measure all the different performance variables, and then we'll figure out what the damping ratio and the natural frequency of the aircraft is for each mode.
Where the students will be examining what's called dynamic stability. If the airplane is perturbed from its steady state flight, what will it do? Will it oscillate? Will it converge to a new position or new attitude? So we'll be doing various maneuvers to excite, as it's called, those modes.
What does industry in New England need? So having faculty that have industry experience is hugely important to us.
I can honestly say that the professors are my favorite part of this program.
We've met a lot of great people. Faculty's easy to work with.
Our staff, they want to pass what they've done onto us.
Professors are required to show expertise in 3 areas: teaching, scholarship, and service.
So what we've seen is a faculty that is flourishing here.
We are, if not unique, one of the very few who have this.
If you want to be an aeronautical engineer, you know, there's 2 choices in New England, MIT or now SNHU.